You are provided with 0.1 capital M sodium hydroxide solution F. So this one is 0.1 capital M sodium hydroxide called solution F. Solution G is made by dissolving 23.46 grams of a diabasic acid in 250 centimeters cube of distilled water. Very important. Kuna kitu hapa nataka ujue. I want you to know what is a diabasic acid. We have monobasic acid. Examples of monobasic acid is HCl. It has got only one hydrogen. Monobasic. Nitric acid. Monobasic. Diabasic is an acid like sulfuric acid. So this acid here is an example of sulfuric acid. So if you know how to write equation with bases using sulfuric acid, this one is not going to give you a problem. So this diabasic acid was dissolved, 23.4 grams of diabasic acid was dissolved in 250. Very important that this is the mass in 250, not in 1,000, but this mass is in 250 centimeters cube. So you are required to determine to dilute solution G, standardize that. So we are going to dilute this solution G. Procedure 1. Using a measuring cylinder, measure 20 centimeters cube of solution G and transfer it into a beaker. Measure 80 centimeters cube of distilled water and add it to the 20 centimeters cube of solution G in a beaker. Label the solution H. Understanding the procedure or whatever you are doing is very important. We are taking 20 solution G, add 80 centimeters cube water, distilled water, and forming 100 centimeters cube solution H, because 20 plus 80 is 100 H. So this H we are forming here, the total volume is 100 centimeters cube, kwa sababu ni 20 G plus 80 centimeters cube of distilled water. And what is H? H is the diabasic acid G. Remember that. H is a diabasic acid G, but diluted now. Procedure 2. Place solution H in a purate. Pipette 25 centimeters cube of solution F into a 250 centimeters cube conical flask. Add 2 to 3 drops of phenolphthalein indicator and titrate with solution H. Record the results. So the results was recorded and we have 14. So let us complete the table. Because we have been given to one decimal place, we will take our initial to be 0.0, 0.0, 0.0. You subtract here, it is going to be 14.1, 13.9, 14.2. So calculate the average volume of solution H. This is the solution of H that was used. So the average is you add this plus this, divide by 3. So our average is 14.10 centimeters cube. Determine the number of moles of solution F in 25. F is sodium hydroxide. F is sodium hydroxide. We have the molarity. Molarity is the number of moles in 1,000. This capital M stands for molarity, and the molarity is the number of moles in 1,000 centimeters cube. So we know that is 0.1 solution F, 0.1 moles actually, moles of solution F are contained in 1,000 centimeters cube. F. What was the volume we used? We have been given it is 25, so we will ask 25 centimeters cube. F will contain how many? 25 times 0.1 divided by 1000. This one will give us 0.0025 moles. So this is the number of moles of sodium hydroxide that reacted with H. Determine the number of moles of acid in solution H in the average volume. Remember this H, we don't know anything about H at all. We only know about the volume. It will be 100. So for us to know some information about H, we must write the reaction between H and F. So the reaction F is sodium hydroxide. So it reacted with H, which is H2MO6. This one here. I told you this one is like sulfuric acid, so you write the equation the way you could have written using sulfuric acid. So you will have sodium sulfate. Instead of sulfate, you write MO6 plus water. It is a salt plus water reaction because this is neutralization. But since sodium here is 2, you balance by writing 2 here, and that is it. The volume for this one is 14.1. The volume for this one is 25. Na tuko na moles yake. The moles of this one is 0.0025. So we are asking the moles of H. This is H in the average. So what was the number? So because the ratio here now you can see the mole ratio of sodium to H2MO6 is 2 to 1. Fine. So meaning that the number of moles of the H acid here is going to be a half. So we are going to, this one is equal to 0.0025. You ask 1 will be what? This one. That is 1 times 0.0025 divided by 2. So the moles of the acid that was used is 0.00125. That is the number of moles of H. Sawa? So it is important kuandika equation, ujue kuandika equation na kubalance. If you don't know that, then it becomes very difficult. Determine the number of moles of acid in 100 centimeters cube of the solution H. Now we know the number of moles of H in 25. Is it in 25? In 14? Because H, the average volume is 14. H, the average is 14. So this moles is the moles of H in 14 centimeters cube. So 14.10 centimeters cube contains 0.00125. We will simply ask what would be 100 centimeters cube. H will contain what? So we simply, this other 100 times 0.00125 we divide by 14.1. That one gives us 0.00865 moles. This is the number of moles in 100 solution H. 100. Determine the number of moles in the acid in 20 in the acid in the question starts here. Determine the number of moles in acid in 25 of the acid in 25 centimeters cube solution G. So you must know what happened. We measured 25 centimeters cube of solution G, diluted it to 100 centimeters cube solution H, meaning that the number of moles in 100 centimeters cube solution H will be exactly the number of moles in 20 centimeters cube solution G, the original. So number of moles in 100 centimeters cube solution H will be equal to the number of moles in 20 centimeters cube solution G. So moles of 20 centimeters cube G will be equal to 0.008865 moles. This one here, because this is the number of moles of H in 100. Number of moles in 250 of solution G. That's very simple now that we know the number of moles of G in 20. So 20 centimeters cube G contains 0.008865 moles. Right? So we will ask 250 centimeters cube G will contain 250 times 0.008865. We divide by 20. And this one gives us 0.1108 moles. So this is the number of moles in 250 G. Calculate the molar mass of acid. The molar mass. Molar mass is the same as RFM. Fine. So there is two ways we can do this. So we can use method 1. We know the number of moles in 250. 250 centimeters cube contains 0.1108 moles, right? And what was the mass in here? We were given the mass in 250. So the mass 23.46, this was the mass also in 250, and it contains 0.1108 moles. So 1 mole will contain what? So that is 1 times 23.46 divided by 0.1108. This one gives us 211.7, and that is the mass in grams per liter. You can simply say RFM is equal to mass over moles. That's what I have done. Method 1 is RFM is equal to mass, this is mass of RFM in 250. So, or method 2, we can get the mass in a liter. So 23.46 grams are in 250 centimeters cube. 1000 a liter centimeters cube will contain how many? That is 1000 times 23.46 divided by 250, and this one will give us 93.84 grams per liter. That is the mass in grams per liter. But we know that molarity is equal to mass in grams per liter divided by RFM, meaning that RFM is equal to mass in grams per liter divided by morality, right? So morality will be, you ask if this is the number of moles in 250, what will be the number of moles in 1,000? 1,000 it will give you 0.4433. So that is 93.84 divided by 0.4433, and that one will be 211.1.71. Determine the mass of M in the formula this, given that H is equal to this and that. So, but we have the RFM. RFM, which is the molar mass, is equal to, we can round off this one to 212. We can round off this 212. So, H2MO6 will be equal to 212. To 212. H is 1, so 1 times 2 plus M plus 16 times 6, the answer is 12 to 12. So this is 2 plus M plus 96 will give us 212. So we can like terms together. So M is equal to 212 minus 2 minus 96. So M is equal to 212 minus 98. So M is equal to 114. You are provided with a solution A, 0.5 molar copper 2 sulfate, solid B1, metal B1 powder, solid B2, iron powder. Solution C is 0.2 molar acidified potassium manganate 7. You are required to determine enthalpy change for the displacement reaction between metal B1 and copper 2 sulfate. Mass of ion that react with copper 2 sulfate in the displacement reaction. Procedure. Using a pipette and a pipette filler, place 25 centimeters cube of solution A into a 100 plastic beaker. Allow to stand for about 1 minute, and then measure the temperature of the solution. Record the reading in table 1 as the initial temperature. Add or solid B. Add solid B to the solution. Start a mixture carefully with the thermometer. Measure the highest temperature reached. This will take about 5 minutes. Record the reading in table 1 as the maximum temperature reached. So I want to give you the values. The maximum temperature reached when the experiment was done was 43.5. Initial temperature, room temperature, was 25. And then when you subtract this, you will get 5. 18. I have kept the decimal point, so once the table is filled up, you get 1 mark. Use of the mass subtraction, you get another mark, and then the decimal point. It is either you will keep a whole number 43, or you may round off to this, or you write in whole numbers avoiding the decimal point, but you can use the decimal point as well. So that is what was expected. Calculate calculated the number of moles of copper 2 sulfate used. Calculated the number of copper 2 sulfate used. So I want to take you back to what we were provided. We were provided with 0.5 mole. This is the number of moles in 1 liter. Therefore, we can easily get the number of moles. Remember, we used 125 centimeters cube of the solution A, which is solution A, 0.5 mole. So we will ask if 0.5 is the number of moles in 1000 centimeters cube. What about 25, the one that was used? We know that 0.5 capital M means that implies that 0.5 is the number of moles which are in 1 liter. Then we ask, what will be the number of moles in 25 centimeters cube of solution A that was used? So it is 25 times 0.5 divided by 1000, and this one is going to give us 0.0125 moles. The enthalpy change for the the question is that here, calculate the enthalpy change for the reaction of metal B1 with 1 mole of copper 2 sulfate. Assume that the mixture specific heat capacity is 4.2 and the density of the solution is water. So here we start by calculating the heat change. Heat change is given by the mass of the solution times specific heat capacity, we use capital C, and then times the temperature change. The solution that was used was 50 centimeters cube. So this 50 centimeters cube is as good as 50 grams of the solution. Now you convert these grams, because we are using the mass of the gram. You convert this from grams to kilograms by dividing 1000. So we will have 50 divided by 1000. This is the mass. Specific heat capacity is 4.2 times temperature change. Our temperature change was 18.5 times 18.5, and this one you multiply this, use your calculator, and it will give you 1.9425 kilojoules. We have used mass in kilograms, therefore we are going to have kilojoules. Okay, now the next thing is to calculate the molar heat capacity, molar. So we know the number of moles that produced this amount of heat. This number of moles of the copper sulfate was able to produce this amount of heat. Now we want to ask, what will be 1 mole, because we want 1 mole we produce. So you will ask that 1.9425 kilojoules were produced by 0.0125 moles. 1 mole will give us what amount? This times this divided by this. So 1 times 1.9425 divided by 0.0125 will give you 155. Use your calculator. 155.4 kilojoules per mole. Kilojoules per mole. But now you ask yourself, was the reaction exothermic or endothermic? Our reaction was exothermic because temperature increased from 25 to 43. Therefore, our final answer is negative 155.4 kilojoules per mole, because our reaction was exothermic. The temperature was increasing from room temperature 25 to 43.5, therefore the reaction was exothermic. Let us go to procedure 2. Repeat procedure 1A, Roman 1, with all the metal B2 iron powder in place of metal B1. The maximum temperature is reached after about 8 minutes. Record the temperature readings in table 2. Retain the mixture for use in procedure 2. So the maximum temperature reached during the experiment was 37.5. Our initial temperature by that time it was 24.0. So when you do the subtraction, you will get it is 13.5, and you get your 3 marks there. The next question is, compare the change in temperature between change T1, temperature change 1, and temperature change 2, and comment on the differences. So we want to compare the temperature 2. The change in temperature 2 is 13.5, and the other one was 18. So that simply tells you that change in temperature 1 is larger or is higher than change in temperature in 2. That's what you can see. So that is what you are going to observe, that change in temperature 1 is larger. You can use larger or is higher than change in temperature 2, because you can see this is 13 and the other one was 18. T1 was 18, T2 is 13. Now, what are you going to comment? We are going to comment that metal B1 is more reactive. It's more reactive than metal B2. Hence, greater temperature change. Temperature change. Now let us look at the titration part of it. Procedure 2. Fill the puree with solution C. Remember, solution C is potassium permanganate, and it is 0.02 molar. So that is something that you must always try to remember from what you are provided with. Remember, you are provided with, you are provided with solution C is 0.02 molar acidified potassium permanganate 7. Don't forget that. Filter the mixture obtained in procedure 2B. Procedure 2B is where we had iron displacing copper into. So put that mixture. If you filter the mixture and then put the mixture in a 250 volumetric flask, wash the residue with distilled water and add it into the flask. Add more distilled water to make up to the mark. Label this solution B2. So here you need to understand this, that what was B2 and so B2 was iron. Iron will react with copper 2 sulfate, whereby iron is more reactive than copper, therefore it will displace copper to form iron 2 sulfate plus copper. Copper will be displaced. So now we have this solution. We have filtered this solution, iron 2 sulfate. Now we are putting this solution into a volumetric flask and then add distilled water to the mark where we will have a total volume of 250 centimeters cube of iron 2 sulfate. So we are going to react iron 2 sulfate with acidified potassium permanganate, right? That is the understanding you need to have. So using a pipette and a pipette filler, place 25 centimeters cube of solution B2. Remember, this is a solution which contains iron 2 ion. That is what you need to understand. Into the conical flask, titrate solution B with solution C until a permanent pink color just appears. Very correct. So this is, remember, this one is an oxidizing agent, so it is going to oxidize iron 2, and then we are going to see. So when the permanent pink color appears, just appears, then we record our table. So these are the values that we want to use. We want to use 22.5, 22.5, 12.2, and then we are going to use 24.5, 24.5. Here the initial, we can even start at 10. It was started at 10. Initial here is 0.0. Initial here is 12.2. So this, I want to show you that it is not a must that our initial is always 0. Initial can be any volume. It is you to decide. So initial is not a must that it should start 0. So when you do this math, you get 12.5. This one is 12.2, and this one is 12.3. So calculate the average volume of solution C used. Now this is the average volume of the potassium permanganate solution. Now because I can see this one is somehow far away from the range of plus or minus 1, so minus 2, I want to leave it out, and I will do the average with only these two. I will do the average with these two, so to be accurate, more accurate. Therefore, I will get 12.2 plus 12.3. You divide it by 2, and this one will give me 12.25 centimeters cube. Let us look at this question. The equation for the reaction between manganate 7 and iron 2 ions is as follows. You can see then this is the manganate and this is the ions, and then the acidification of it. Yes. So calculate the number of moles. Calculate the number of moles of potassium manganate 7 used. The number of moles of potassium manganate 7 used. But we know that 0.02 is the number of moles in 1000 centimeters cube. Solution what? Solution C. Remember that because we were provided with 0.02 molar potassium permanganate. So we have used 12.25. So we will ask 12.25, this volume here. We have used 12.25 of solution C. Solution C, acidified potassium permanganate. So we will ask, what will be the number of moles of this 12 centimeters cube of solution C? What will be the number of moles? So this times this divided by this. That one will give us 0.0000245 moles. So this is the number of moles. It is the number of moles of potassium permanganate. but the ratio between potassium permanganate and the iron is 1 to 5. So the question, calculate the number of moles of iron 2 ions in 25 centimeters cube. Solution B, 25, the one we pipetted. Now, since this is the reaction, we know 1 is equal to this moles. What about 5? Now, mole ratio between the iron and the manganese is 1 to 5. So we just simplify, we multiply this times 5. So moles of iron 2 equal to 1 equal to 5 times 0.000245, which is equal to 0.001225 moles. So this is the moles of the iron in 25. So because 25 centimeters cube is the one that reacted with 12.25 solution C. So those are the things you need to understand. Now the next, we calculate the number of moles of iron that reacted with copper 2 sulfate. I have already showed you the reaction that took place. The initial reaction that took place is that copper 2 sulfate was displaced by iron to form iron 2 sulfate plus what? Plus copper. And then this solution was added water. This solution was added water to make 250 centimeters cube. So, and this is the iron. So if 25 of this iron, 25 has these moles, what will be the number of moles in 250? The one that reacted with the copper. So you just simply ask 25 centimeters cube of the iron is 0.001225. What about 250 centimeters cube of the iron? What will be the number of moles? So this times this divided by this, and that one will give you 0.01225 moles. Yes. Determine the mass of the iron. Determine the mass of the iron that reacted. Now we have the RM of the iron as 55.8, but we know that mass equal to moles times RAM. Sorry. And the number of moles of the iron that reacted with the mass. Determine the mass of the iron that reacted. The mass of the iron that reacted with copper. We have the number of moles of the iron. Yes, we have the number of moles of the iron. Therefore, we have the RM of the iron. We just get that it is these moles times 55.8, which will give you 0.6836 grams. That is the mass of